It's a pleasure to meet you all once again with grade 10 ICT video tutorial. This is the fourth tutorial, fourth class to be recorded. We have completed 3 video lessons and covered the basic parts of number systems, which means the characteristics and the features and the usage of those number systems. And also we have covered 6 various conversions, number conversions in the previous classes. I try to take a minute or two to recall the conversions which we have studied over the last 3 classes. We started off the conversions with decimal to binary. Then we took decimal to octal and then decimal to hexadecimal. These are from decimal to other number systems. And then in the third video tutorial, we had the opposite conversions, which means conversion of binary, octal, hexadecimal into decimal. So far we have completed 6 various conversions. I hope you all remember those conversions because I have mentioned some of the shortcut methods to remember those methods for converting one number system into another. So in decimal to other number system, there is a format found. There is a method found. Even in the opposite conversion from binary, octal, hexadecimal to decimal also, there is a pattern found. I have mentioned it. Hope you remember them, and also I hope you all took some time for practicing. Today we have to take another conversion, which means 7 conversion. Before I take the next conversion, I must tell you one more thing. See, in all these 6 conversions, which we have taken, you can see the decimal number system as a part in all these 6 conversions. So decimal to binary, decimal to octal, decimal to hexadecimal, binary to decimal, octal to decimal, hexadecimal to decimal. So since decimal number system is a part of all these 6 conversions, it is too easy to remember those patterns or those methods, right? So hereafter, in the upcoming 4 conversions, in the next 4 conversions, we will have binary number system as a part in each conversions. So in the previous 6, we had decimal as a part. In the next 4, we will have binary number system as a part. So let's take the conversion number 7, right? Conversion number 7. Here we are going to convert a binary number into octal. So this is conversion number 7, binary to octal. So straight away I take a binary number. So let me take 1 1 0 1 1 1 base 2. It's a binary number. We have to convert this into octal. To convert this binary number into octal, even without any introduction, you can the knowledge that you gain from the past 6 conversion. If you use those knowledge that you gained in the past 6 conversion, you can convert this binary into octal. There is no issue because here it's a binary number. You know how to convert this binary number into decimal. So first of all, you have to convert this into decimal. So once a decimal number is obtained, you have to convert it further into octal. So let's try that first. So here we have binary. Let's convert this into decimal. So to convert a binary into decimal, first of all, I have to write it again, 1 1 0 1 1 1. So first of all, we have to write the position of each digits in the binary number. So you know this is 2 to the power 0. The first digit is always in the position of 2 to the power 0. So here in the second digit is in 2 to the power first position. Then the third digit is in 2 to the power second position. Then it will be 2 to the power 3. It is 2 to the power 4. It is 2 to the power 5. So I have written the positions of all the digits. So thereafter, hope you remember the methods because we have already studied this. So hereafter, we have to take the value of this. So 2 to the power 0, it is always 1. 1 into, look at the number which belongs to this position, that is 1. So it is, you have to multiply both of them. So go to the second one, 2 to the power 1, it's always 2 into, look at the digit, it's 1, so it is 2. Then the third one, 2 to the power 2, it's 4. 4 into, look at here, it's 1. 4 into 1, it's 4. The next one, it is 2 to the power 3, which means 8 into, look at the digit, it's 0. So 8 times 0, it's 0. The next one, 2 to the power 4, is 16. So 16 into 1, it's 1. Sorry, it is 16. Then 2 to the power 5, it's 32 into, look here, it's 1, it's 32. You have obtained the values for each and every position. So finally, add all these numbers together. It is 55. So this is equal to 55. But hope you remember the question. It is not binary to decimal. The one which we obtained here is not an octal number. It's a decimal number. So still we have to take some steps. We are few steps away. So now this decimal number has to be converted into octal. So I have obtained 55. This is decimal number. This has to be converted into octal. So again, you have to remember, you have to use that method to convert a decimal number to any other number system. You must divide that decimal by the base of the particular number. So here in my case, I'm going to convert this 55 into octal. So it is 8. So I must divide this 55 by 8. So it is 6 times or 6 quotient, 7 a remainder. Since it's 6, we can divide further. Look here, 6 is smaller than 8. So it is 0 times and put the 6 as remainder. So since the quotient is 0, you cannot divide further. So your answer would be 6, 7 base 8. So 110,111 is equal to 6, 7 base 8. But you can notice here, to convert this binary into octal, firstly I converted into decimal. Thereafter, I converted the decimal into octal. So you might have observed that I have taken some time, more time. At the same time, I have done many calculations because we were working with 2 different conversions. So this may be the issue in this conversion because you have to spend more time in converting your numbers. At the same time, since you have many methods or many steps, there is always a possibility for making mistakes. So I'm not going to recommend this method to you to use in examinations. This may be okay, this is correct. If you use in examination, they definitely accept. But since we have to manage all our conversion within the time, I'm not going to use this method, or I'm not going to suggest this method to you to use in examinations. So we will take another method or another way to find an octal value for binary. So right, let's convert this same number into octal in a different method. That may be that should be the method used in examination, or that may be the method suggested even in your textbook. So here you have 6 binary digits. So the first step, what I'm going to do is going to form groups of 3 bits starting from right side. So I have to divide these 6 binary digits into multiple groups. Make sure every group has 3 bits. But that grouping must be started from right side. I tell you the reason for making groups and having 3 bits in each group later after writing that. So you have to divide this binary number into multiple groups, but that must be divided from right side. So here I have 1, 1, 1 in the first group. These 3 must be in one group. The rest of the numbers, they are also 3 digits, so they must be in another group. So what I did was form 2 groups and making sure each group has 3 bits. So here there is a reason for making groups and having 3 bits in every group. So we all know the base of binary number is 2. The base of octal number is 8. So we have base 2 for binary and base 8 for octal. So there is a relationship or there is a connection between the binary and the octal. So look here, it is 3, it is 8. So we can say that 2 to the power 3 is always 8, right? So it is very simple connection between binary and octal. So let me explain that, or let me suggest that particular idea. To represent an octal number, you must have 3 binary digits. I repeat my wording again. For representing an octal digit, one octal digit, you must use 3 binary digits, because 2 to the power 3 is always 8. For representing one octal, definitely you need 3 bits, 3 binary digits. Or even I can say this particular connection in a different manner. So 3 binary numbers or 3 binary digits are needed for representing one octal character. So if you have 3 binary digits, definitely you can represent one octal character. So look here, you have 6 binary digits. So the reason for making 3 bits group is to represent an octal character by these 3. So look here, we have 3. So with the help of these 3 digits, one octal digit can be represented. I don't know what it is, but definitely there is an octal character. We can find out that later. So look here, you have another 3 bits. So here also these 3 bits can represent another octal digit. So for example, I put X and Y, but there is an octal digit. You know, octal digits are there from 0 to 7. So they should be one digit. So that's the reason why we formed groups and make sure every group has 3 bits. So because 3 bits can represent one octal digit. So these 3 bits can represent one octal. These are different 3 bits. So these 3 bits can represent another octal digit. I have to mention one more thing. I told you that the grouping must be done from right side. So starting from right side. There is a reason for that also, but I am not going to explain the reason here. In the second example, I will explain the reason for grouping from the right side. Even for this example, grouping from right side or grouping from left side are not matters. Both may be okay, both may be correct, but in some cases definitely you have to start your grouping from right side. I tell you the reason later. So this is the first method to be done. You have to making groups. You have to make groups of 3 bits starting from right side. So I have I have 111 and 110. One more thing, look here, this is one number. This seems to be one number. Yes, that's one number. But that one number has been broken into 2 parts. So now 111 is a number, 110 is another number, because since the number has been divided into 2, definitely there are 2 numbers. That is important to go to the next step. So now the next step would be writing the position of each digits. So look here, it's a binary number. So I can write the position as 2 to the power 0. Second one, where it is in 2 to the power first position. Here it is 2 to the power second position. After dividing into groups, I have to write the positions of each digits. Since it's a binary number, we have written the positions as the power of 2. Similarly, you have to write those positions to the next number. As I mentioned earlier, this is another number. So you cannot write like 2 to the power 3 because it's another number. Earlier it was one number, but since it is broken, definitely it's another number. So here it is the first digit, so it is 2 to the power 0 position. It is 2 to the power 1, it is 2 to the power 2. Right? So there is no confusions at all, because one number, it is divided into 2. So here we have one number, here there is another number. So definitely you need to start your values again. You cannot put 2 to the power 3 there. Right? So now get the value of this, get the value of those powers. So here 2 to the power 0, it's 1. Multiply that 1 into 1. So 1 into 1, 1. Again, look here, look at the method. 2 to the power 0, it's 1. 1 into 1. You have to multiply with the digit. So it's 1. Plus, you need to add the other numbers, so plus. 2 to the power 1, it's 2. So 2 multiplied by 1. So 2 into 1, it's 2. Plus 2 to the power 2, it's 4. 4 into 1, it's 4. Add all those numbers together. So 4, 2, 1 is 7. It's very simple. The binary numbers 1, 1, 1 represent an octal digit 7, because 7 is a valid number in octal. You have 3 binary. Those 3 binary digits represent one octal character, that is 7. Do the same method or do the same idea for the next number. So here it is 2 to the power 0. So it's 1. 1 into 0, it becomes 0. Plus 2 to the power 1, it's 2. 2 into 1, it's 2. Plus 2 to the power 2, it's 4. 4 into 1, it's 4. So 4 plus 2, it's 6. Here also 1, 1, 0. These 3 binary digits represent one octal character, that is 6. So these 3 binary represent 6. These 3 binary digits represent 7. So finally, you have to write both of them together, 6, 7, 8. The reason for writing both of them together is, look here, this was one number, 1, 1, 0, 1, 1, 1. That one number, that single number, was divided into two halves, two parts. So one part here, the other part there. This part is equal to 6. This part is equal to 7. So we divide one single number into two halves. So to get the original back, those two parts must be joined or must be merged once again. So that's why 6, 7, both digits are joined together and you got 6, 7. So this is equal to 6, 7 base 8. So this is too easy because you have less number of steps here and also only direct conversion. But in the previous method, you faced two conversions. You have written plenty of steps. So they killed your time, and also like I mentioned earlier, possibility for making mistakes is always high. But here it's very simple. So check that again. To convert a binary number into octal, first of all, divide your binary number from right side to have 3 bits group. The reason for having a 3 bits group is 3 binary numbers or 3 binary digits are needed to represent or to show one octal character. So that's why we divide the binary by groups and include 3 binary digits. After dividing, you have to write their position. Finally, find the value and write them together. So it's 6, 7 base 8. So let's take one more example. So look here, I have 1, 1, 1, 0, 1, 1, 0, base 2. Look at this, you have 7 digits here. 3, 3, 1, so you have 7 digits. The question is same, converting this binary into octal. So now you may have some issues for grouping, because in my previous example I had only 6 characters or 6 digits, so I could easily form the groups including 3 bits, but here I have 7 bits. So if I form this group like this, assume I group these 3 ones first, so one group, next 3 digits, so 0, 1, 1, another group. So now you have only 0. So look here, according to the connection between binary and octal, you need or you definitely need 3 binary to representing one octal. Yes, you have 3 binary for representing octal, that's okay. Here also you have 3 binary, it's okay. But here you have only single digit. How can you represent octal character by using a single binary digit? That is impossible. You cannot do that. So definitely you need 3 binary digit for representing an octal character. So for making this as 3, what happens if you add zeros there? Now if you add 2 zeros becoming that as 3, now it's wrong, because look here, these two numbers are different. If I add these two zeros here, the value, this number, definitely, the value of this number definitely changed. You cannot do that. Yes, you may add the zeros, but without changing the value. But now, once I added 2 zeros, the value of that particular number was changed. So I cannot do this. So this may be the reason why we divide we form the groups from right side. So let's form the group from right side. So look here, 1, 1, 0, that is my first group. Look carefully, I'm grouping from right side. So this is my first group that includes 3 digits, 1, 1, 0. Look at the second one, these 3, 1, 1, 0 again. Finally, I have 1. But here also you have the same problem, because to represent an octal character or to represent a binary by octal, definitely you need three binary, but you have only one binary digit. So by using one binary, you cannot represent an octal digit. So here also we have problem, but that problem can easily be managed, because if you want three digits, let's add two zeros. Now look at them, you have three digits. At the same time, you all know that two zeros in front do not have any values. So by adding these two zeros, your number is not changed. The value of your number remains same. So that may be okay. But if you start grouping from left side, definitely you will have problems. So be careful when you are grouping. Make sure you start from right side. From that side, right side, right? Okay. Now we have those three groups. So now it's very simple. These three digits can be represented or can represent one octal digit. So let's find out what it is. Similarly, these three binary digits can represent another octal digit. These three binary can represent another octal digit. So let's find out that. So first of all, write the positions. So here it is 2 to the power 0, 2 to the power 1, 2 to the power 2. This is another number because that number has been divided into multiple parts. So it is another number. So where this 0 located, it is in 2 to the power 0 position. It is 2 to the power 1, 2 to the power 2. You have another number, so definitely it is in 2 to the power 0 position. 2 to the power 1, 2 to the power 2. Right, so I have formed three groups and also written the position of each digits in each group. So what is the next step? You need to find out the values for each position. So look here, it is 2 to the power 0, it's 1, 1 into 0, it's 0. Plus 2 to the power 1, it's 2, 2 into 1, it's 2. Plus 2 to the power 2 is 4, 4 into 1, it's 4. So 1, 1, 0. These three binary digits represent what? It is 6. This is octal digit. These are three binary digits. Let's find out here. 2 to the power 0 is 1, 1 into 0, 0. Plus 2 to the power 1, 2, 2 into 1, it's 2. 2 to the power 2 is 4, 4 into 1, 4. So here also same idea, 6. Because look at them, 1, 1, 0, here also 1, 1, 0, same value. The next one, next group, 2 to the power 0, it is 1, 1 into 1, 1. Plus 2 to the power 1 is 2, 2 into 0, you have to multiply it by 0, so it becomes 0. 2 to the power 2 is 4, 4 into 0 is 0. So add them, it's 1. That one number was broken into three parts. To get it back to the original number, you need to write them together. So it is 166 base 8. That's the number. Right? So remember this idea. For converting a binary into octal, you have to form groups from right side and make sure that you have 3 bits in every group. Right? So this is binary to octal. Now we have to take the opposite one, the vice versa of this one, converting an octal number into binary. So let's see how to do that. This is octal to binary. So straight away I take one simple example. Okay, I have 7, 5 base 8. It's an octal number. Let's find out the binary. For finding the binary values, you may use multiple conversion. In fact, 2 conversions from the conversions which we learned earlier. So here, look at them. This is octal. So first of all, you can convert this octal into decimal. right? So once the decimal value is obtained, you have to further convert the decimal into binary. That may be okay. Even in the previous conversion, we explained, or we had two methods or two conversions. So here also that is possible. I repeat it. It's an octal number. Have to be converted into binary. Yes, you can convert this octal into decimal first. After that, that decimal can be converted into binary. That is possible, of course, that is correct. But again, I'm not going to recommend that for your exams or for your studies, because as we had in the previous conversion, they definitely need many steps, and also definitely they take more time. So forget about that method. If you want, you can remember and you can work, but I want to convert this directly into binary. I'm not going to take the previous conversions or previous methods. Straight away, I will convert this by octal into binary. So let's see how to convert this octal into binary. First of all, check the number of octal digits located or added in this number. So how many octal digits are here? 2, right? So 7 is one octal digit, 5 is another octal digit. So it's an octal digit, it's another octal digit. Even for this conversion, you have to remember that particular connection between binary to octal. Whenever you are asked in examination with binary to octal or octal to binary, you must think about that particular connection which I have suggested earlier. 3 binary numbers are needed for representing one octal character, or in another word, one octal character can represent 3 binary digits. Keep that in your mind, because whenever you have such conversions, that particular connection must be in your mind. So look here, I have 2 octal digits. This first octal digit needs 3 binary digits. I don't know what they are, but I know there should be 3 binary digits because it's an octal digit. I'm going to convert this octal digit into binary, so I need 3 binary digits. Look here also, this is also one octal digit, so definitely I need 3 binary digits. This is very simple. You have 2 octal digits, both of them definitely need 3 bits each. So 7 needs 3 bits, 5 needs 3 bits. The only thing is, you have to find them. You have to find those 3 bits. It's very simple. Look at them. First of all, find out the 3 bits for 7. It's a very simple method. Whenever you want binary, because I want binary digits, here I put like X, but definitely there must be ones and zeros. So to get binary values for this 7, there is always one method, that is dividing that 7 by 2. So because it's binary 2. So divide that 3 times 1 remainder. Further divide that 1 time 1 remainder. Divide it further 2, so 0, because 1 is smaller. So 0 times 1 remainder. So this octal digit 7 is equal to binary numbers 1, 1, 1. This is 1, 1, 1. One octal, it represents 3 bits. Next, we have to find the 3 binary digits for number 5. So do that division also. So you have to divide that 5 by 2. So 2 times remainder 1. Divide it again. So 1 time remainder 0. Further divide 0 times remainder 1. Now this 5 can be represented by 1, 0. Right? So 7 is represented by 1, 1, 1. 5 is represented by 1, 0, 1. So one number, you have two groups. Write those two groups together because it's a one number which has two digits. So here also this belongs to 7, this belongs to 5. Write them together. 1, 1, 1, 1, 0, 1. There's 2. This is the equivalent value for 7, 5 is 8. Right? So again see the method. It's an octal number. This number has 2 octal digits. So as we discussed earlier, 1 octal digit represents 3 binary. So in other words, to represent an octal number, we need 3 bits. So there are 3 bits. For 5 also there are 3 bits. So how to find those 3 bits? Divide those characters or divide those digits by the base of binary, which is 2, and get the reminders. Finally, write them together. So this is the answer. Let's take another example, because here you don't have any issue, because in all these two groups, in both groups, you have three bits. So there is no issue, you just wrote them together. But sometimes you may have 2 digits. You may have 2 digits here, you may have 1 digit there. So there may be some issue. Let's see how to solve or how to do such things. So look here, 6, 2, 3, base 8. Check the digits 6, 2, 3. All these 3 digits are valid in octal digit. So now we have to convert this into binary. So hope you remember the method. We have 3 digits. Every digit needs 3 bits. So this 6 needs 3 bits. For examination, you don't need to put those marks. I am writing here in order to explain. Then only you can easily understand. That's why I am writing there. But for examination, you can straight away write those bits after finding or after doing such calculations, right? So this 2 also needs 3 bits. This 3 also needs 3 bits. Right? For the reason why I have written 3 bits there is 3 bits needed for representing one octal character. I keep repeating such dialogue because they are very important when you are working with binary octal, right? Now let's find out the 3 binary for the 6 and 3 binary for 2 and 3 binary for 3. First of all, I have to take 3. So convert this divide by 3 by 2. 1 time, 1 remainder. Further divide. So it is 0 times 1 remainder. So this octal digit 3 is represented by binary digits 1, 1. Right? Let's go to the second one. It's 2. Have to convert this 2 into binary. So divide by 2. 1 remainder. 1 quotient, 0 remainder. Divide it again. 0 time, 1 remainder. So it's 1 0. It's 1 0. Next one, 6. So to take 6, divide by 2. 3 quotient, 0 remainder. Divide again. 1 quotient, 1 remainder. Divide again. 0 quotient, 1 remainder. So it's 1 1 0. So now look here, this 6 represents 1 1 0, 2 represents 1 0, 3 represents 1 1. So as a student, now you may think that you have to write all these 3 groups together for getting your final answer. So if you write all these three groups together, definitely your answer is incorrect, because look here, look at this digit 3 is equal to 1 1. Maybe okay, that's correct, but you all know that connection between binary and octal. This is octal digit. To represent this octal digit in binary, definitely you need 3 binary digits. You cannot use 2 binary digits for representing or for displaying one single octal character. But in this example, I am trying to represent this digit 3, octal digit 3, by 2 binary digits, only using 2 binary digits. That cannot be. I cannot do that. So I need 3 bits. So what I am going to do this is add the 0 in front. We all know that 0 in front of any number doesn't have any value. So now look at them, 0, 1, 1. This 0 doesn't have any value. At the same time, now this set satisfies our rule or satisfies our connection. So now it's okay. We are in line with our rules. That is okay. Look here also you have a problem. Now you might have observed, yes, it's an octal digit that is represented by 1 0. Here also you cannot do that, because 2 binary digits cannot be used for representing one octal. So here also definitely you need 3 bits. So definitely you need to add a 0 here. Right? But here look at them, you have 3 bits, no issues at all. So keep them as they are. But here definitely you have to add 0. Some of you may think that adding a 0 in front doesn't have any value. So you may think that adding 0 or not adding 0 is same. Yes, it may be okay. Look at them. I'm hiding the other numbers. Look at this set only. 0, 1 seems to be meaningless. Yes, meaningless, because 0 in front is always meaningless. But remember, now this 0 is in front of these 3 bits. But after that, after some time, I have to write all these 3 sets together. So note, when I write all these 3 sets together, this 0 must be somewhere in the middle, not in the beginning. Have you understood? Now it is in the beginning, so it may not have any value. But the thing is, you have to write all these bits together to get your final answer. So when you do so, this 0 must be somewhere in the middle. Definitely that 0 has a value. So ignoring this 0 definitely is incorrect. You must put the 0. Hope you understood my explanation. So here also, look here, this 0, the front 0 may not have any value here. That 0 doesn't make any sense now. So you may think that I'm adding a 0 without having any value. Maybe okay, at this moment it's okay, but the thing is, this 0 also somewhere in the middle after we joined all the numbers. So make sure when you have 2 numbers, so when you have less than 3 digits, you have to add zeros in front and to take them as 3 digits. So now 3 digits, 3 digits, 3 digits. So now write them together. So 1 1 0 0 1 0 0 1 1 is 2. This is the answer. Right? So whenever you are working with this kind of a conversion, there is always a possibility for making such mistakes. Try to be very careful, because that is one of the common mistakes made by students in examinations. Right? So this is how an octal number is converted into binary. Right, so today we have taken only 2 conversions. I started off with binary to octal, then we took octal to binary. since we have taken some more exercises, we took some time also. So these are enough for today. Again, the important thing is practice. You need to practice these conversions again and again. But whenever you practice, don't memorize anything. Try to remember the methods and the theories and the connection, everything in your mind. Then only you can understand, or you can remember them forever. So up to now, we have completed 8 conversions. In the first 6, where they are very easy to remember. Even in the last 2 conversions are easy for those who are following my steps, or who are listening to my particular connections and everything. So hope everyone will have some time at home, will spend some time at home for practicing these conversions. So hereafter, in the next video tutorial, we will take another 2 conversions. There we will convert a binary number into hexadecimal, and also a hexadecimal into binary. If you understand today's 2 conversions clearly, without any doubt, understanding the next 2 conversions is very simple, right? So that's it for today. We will meet in the next class. Thank you for watching.